Welcome. My previous video cut on law number 5, complement of a complement, which states that the complement of a complement leaves the original variable unchanged as illustrated. So now the last law, which is property number 6, it's the 1 and 0 theorem. So the 1 and 0 theorem states that any variable that is odd with a 1 produces a 1, and a variable ANDed with 0 produces a 0. So I shall also illustrate that. Any variable, let's take A, when it's odd with a 1, okay, when it's odd with a 1, and any variable that is ANDed with a 0. So now the 1 and 0 theorem states that any variable that is odd with a 1 produces a 1, any variable that is ANDed with a 0 produces a 0. And that's what this property states. Now these are the 6 properties of Boolean algebra. Now let me take you a bit back on Boolean logical output. So when it's 1, you should think of it as true, or it's on or high, and when it's 0, think of it as false, off, or low. It's just logic. Okay, 1, 0, meaning it's high or it's low. When it's 0, then 1 can also represent true, 0 false. So like 0 is mostly on the negative, while 1 is on the positive. That's why it's having true, on, high, while 0 is having false, off, and low. And also another thing you should take note is a variable, when it's not complemented, it takes on the value of 1, and when it's complemented, it takes on the value of 0. So I'm going to just sum up the properties that we've looked at. The laws that you should have in your head are those. First of all, illustrating numbers, then we'll look at them in letters. So let's start with numbers. So think of an AND gate as a multiplication sign. That's how it works. So for example, here we have 0 dot 0. That's the same as 0 times 0, which is 0. 0 times 1, it's 0. 1 times 0, it's 0. And 1 times 1, it's 1 in Boolean algebra. Okay, so it's just like a normal multiplication here, but because we are dealing with 1s and 0s, we can't put to it. Everything here should be 1 and 0. So logically here, when you're multiplying 1 times 1, it's always 1, and any number multiplied by 0 is equal to 0. So this part we're done. Now we're looking at product laws, by the way, and as you can see, this is the table you should have in your head. So already here we have identity property. If you remember what it states, that any variable that is ANDed with a 1 produces that same variable. Okay, that is the identity law. And then we have the 1 and 0 theorem there as well. Any variable that is ANDed with a 0 produces a 0. So you see, these laws, you move with them all the way, whether you like it or not. So you just have to know that. So A times A, it's A. Should know always A times A. They are not complemented, as you can see. The only letter that's complemented is this one here, but the first line here, no letter is complemented. A times A, it's A, which is the same as 1 times 1, it's 1. So since we are dealing with letters, it only makes sense to say so we do A times A is equal to A. And then when we do A times 0, remember what I said? Think of a variable that's complemented carrying the value of 0, and we know that any number you multiply it by 0, it's 0. So A times a complement, the answer will be 0 because it's the same as you're multiplying 1 times 0. So the answer is 0. And here the identity law, according to the identity law, a, when it's ANDed with the 1, it's equal to a. If we do normal multiplication, it's the same as a. If it comes times 1, a times 1, it's just a. It will only come one time. And then here, the 1 and 0 theorem, same thing. When you're multiplying 1 times 0, it is 0. So here there's already a 0, and this letter is not complemented, meaning it's having the value of 1. And then this letter times 0, it's obviously 0, because let's say we put a 1 here times 0, it will still be 0. So these are the product laws you should know. And then moving on, we look at the sum laws. We start with numbers as well. When you're looking at the sum laws, look at them, or get as a plus sign, okay, like an addition sign. So here we do normal calculations. 0 plus 0, it's 0. 0 plus 1, it's 1. 1 plus 0, it's 1. And 1 plus 1, normally it will be 2, but in Boolean algebra it's just going to be 1. Okay, so this is it. You should just know the difference is just here. 1 plus 1, here it's going to be 1. Okay, so these are actually the laws of Boolean algebra in numbers. Now let's go to letters. So we're still on the sum laws. When we do a plus a, it's definitely going to give us a, because like I said, it's the same as 1 plus 1 is equal to 1. And since we're dealing with letters, a plus a, it's a. And then a plus a complement is equal to 1, because this a is complemented, so we can as well say the 0 here. So a plus 0, 1 plus 0, it's 1. So this a is having the value of 1, and this complemented a is having the value of 0. So 1 plus 0, it's 1. That's why a plus a complement is 1. Then a plus 0, it's going to be a. This is normal addition, it's not multiplication. If it was multiplication, here would have an answer to be 0, but then since it's addition, a plus 0, it's a. And it's the same as if you add 0 to a, it won't be added or subtracted, it will just remain a, because we're adding nothing to it. 0 is the same as nothing. And then here a plus 1, it's 1. So any variable that's odd with a 1, it's equal to 1. 1 in Zero Theorem. This one here, it's identity. So you can see the two laws, identity and 1 and 0 theorem, are still following us. This is identity, and then this one is 1 and 0 theorem. Okay, they'll always follow us. We cannot avoid them, so you just have to have all this in your head. Yep, so from here, these are the only laws and properties that you should know about Boolean algebra. And of course, when we're talking about the gets, just make sure you have this in the head. The AND get is represented by a dot, the OR get is represented by a plus, the NOT get is represented by an over bar, or what we call a complement, but then don't use this sign here. Okay, I'm just using it for illustration purposes. Use an over bar. Okay, don't use the inverted commas. So just an image representation of an AND get, which is symbolically represented by a dot, and then this is how it looks like in a picture form. You can see the shape is different from an OR get. This is how an OR get looks like, represented symbolically by a plus, of course. And then of course a NOT get, this is how a NOT get looks like. So this is it about Boolean algebra that you need to know. Look out, or rather watch out for my next tutorial as we advance.